Deep in the Indian Ocean lies a massive scrap of volcanic rock, forming what's known as the Mascarene Plateau. Peaking above the water in only a handful of spots, the vast majority of this platform sits just meters beneath the surface, creating a remarkably rich yet isolated shallow water environment. If you're a fan of this channel, you should be well familiar with this place by now, as we've looked at it a number of times already. We first learned about its existence through my Earth's Lost Continents video. Then we learned how just a few thousand years ago, parts of it had been dry land through my video on Earth's Lost Islands. We then used that information to figure out why seagrasses and not corals cover this shelf in the biogeography of the ocean video. And most recently, we revisited these isolated sea meadows to learn how they led to the evolution of a population of pygmy blue whales. I think it's safe to say I talk about this place a lot, though to tell the truth, I didn't really do this on purpose. Like, I never set out to do a deep dive into this area, and yet somehow we ended up learning about its geology, its past geography, its peculiar biology, and its thriving ecology, to the point where I think I've explored the Mascarene Plateau more times than any other feature on this channel. And I think a lot of my fascination surrounding this place comes from the fact that we don't really know much about it. Being hundreds of miles away from the nearest land, this area is naturally difficult to access and even harder to maintain a long-term presence in. As a result, the Mascarene Plateau has remained largely unexplored until rather recently. Initial surveys were only conducted by the late 1960s, which gave us our first glimpse into the area's topography. This is how we came to realize the Mascarene wasn't one solid plateau, but rather a cluster of plateaus, including the Amirante, Seychelles, and Fortune Banks all the way up here in the north, and then Réunion, Mauritius, and Nazareth Bank further south. Each of these underwater mountains peak above the surface in at least one spot, revealing the landmass below through a number of islands. But between all these islands lies the biggest piece of the plateau, the Saya de Malha Bank. Despite covering over 60,000 square kilometers, not a single scrap of this rock reaches above the water, making it the most remote corner of an already remote continental fragment. Because of this, it wasn't until 2002 that a proper scientific expedition was mounted to thoroughly investigate the geology, biology, and ecology of this bank, the findings of which were published in this report. As such, I've ended up using this as a source in my videos multiple times now, as on the surface it appears to be nothing more than your typical mission summary. It was only after being forced to read this report again and again that I finally read a little deeper into it and came to the realization that this was anything but your basic research expedition. And in fact, buried within these pages is a much more elaborate plan. One that sought to change the very landscape of this ocean oasis, from a secluded sea meadow into a hub of scientific research and international trade, all by creating new land in the middle of the ocean, using a method that's never been used before, one that could supposedly build islands using nothing but electricity. So today, let's dive into this report and try to figure out why someone would want to do this, if somebody really could do this, and if it all ended up being worth it in the end. Opening this up to the introduction, we'll read the Saya de Malha banks are one of the least known shallow marine ecosystems in the world. As they are avoided as a potential hazard to navigation, little mapping or scientific research has been carried out there prior to this expedition. This fits into what I was saying earlier, as the plateau sits nearly 900 kilometers from the nearest land in the Seychelles, 1,000 kilometers from Mauritius, and over 1,200 kilometers away from Madagascar. Simply put, the Saya de Malha Bank is just too far away from land to ever be thoroughly studied, which is unfortunate because one of the few things that we do know about it is how the rich supply of nutrients and plankton delivered to to the banks from adjacent deep waters make the banks an oasis of high productivity. This is something else I've explained before using a map like this, where we can see the oceanic chlorophyll concentrations. Chlorophyll is what plants and plankton use to turn sunlight into energy, so a map of chlorophyll's distribution shows us where photosynthesis is happening in the ocean. And if we look closely, we'll see the many banks of this plateau stand out clearly against their surroundings, revealing the heightened amount of photosynthesis taking place here. Altogether, what the intro of this report has made clear is that the Saya de Malha bank is both incredibly rich in life and yet has barely ever been studied, explaining why the stated goals of this expedition were to make a first assessment of the flora and fauna of selected areas of the bank, to make an initial assessment of the ecological significance of the researched area, and documentation and reports on this relatively unknown area in the Indian Ocean. This pretty much answers my first question as to why someone would want to venture all the way out here. And so by this point, still nothing really seems out of the ordinary. But what if I told you all of these objectives were simply a cover for one final goal buried within this report, the building of a coral ark, our first clue as to the true motivations behind this expedition. To figure out where this goal comes from and what a coral ark even is, we need to continue flipping through this until we find the roster of participants. Like any audacious plan, the story of this one begins with a single person. This man, Professor Wolf Hilberts, the self-described expedition leader whose accolades include being the first to formulate Cybertecture and inventing mineral accretion technology. To fully understand this story, we first need to fully understand this man. And to do that, we first need a lesson in what the heck Cybertecture and mineral accretion technology even means. Lucky for us, Hilberts wrote this article for the magazine Progressive Architecture all the way back in the 1970s, where he first makes the case for a concept of his own invention, what he called Cybertecture, or the combination of cybernetics and architecture. While it's almost impossible to give a brief overview of what exactly that entailed in his own words, if we examine and consciously integrate the principles and mechanisms of evolutionary processes into technology, we will discover man-machine and machine-made environments with new, unheard of capabilities. Did you pick up on that? Here, let me read it again. Integrate the principles and mechanisms of evolutionary processes into technology. Or how about just to integrate evolutionary processes into technology? At its heart, Cybertecture was an attempt at studying how nature assembled complex structures and look for ways of incorporating these methods into our own building practices with the hopes of being more sustainable. Which honestly isn't a horrible idea, and dare I say, even perhaps possible. I mean, there are numerous examples of animal constructions, from termites building towers to beavers building dams or corals building up entire atolls. So it's not really all that crazy to suggest that we try taking advantage of this somehow. And that last idea in particular, to somehow harness coral's propensity for constructing huge rocky platforms in the middle of the ocean, is evidently the idea Wolf ran with, as if we flip to the very end of this article, we'll get to see exactly how he first envisioned such a cybertectural world, and we get a true sense of the scale of what he was trying to accomplish. Wolf wanted to build cities in the middle of the ocean. Or better yet, he wanted to figure out how to convince corals to build a city for him. Initially, Wolf thought this could be done simply by erecting a basic metal structure and allowing corals to cover it, encasing the framework with their hard calcium carbonate bodies, thereby strengthening it. There were only two problems with this plan. First, corals don't like attaching to cold, hard metal surfaces. And second, even when they would attach, corals grow far too slowly to ever produce any tangible results on their own. Frustrated by this, Wolf started looking for ways of getting around relying on coral. If he could figure out how they took minerals from the water to build their shells, then he could simply mimic this process and build whatever he wanted. After 9 years of pursuing this goal, he eventually published this paper in the Journal of Oceanic Engineering, describing his experiments and applications for the electrodeposition of minerals in seawater. And this, he believed, was his big breakthrough. So much so, in fact, that he patented this process as his own mineral accretion technology. And here, his method was laid out plain and simple. Take 2 conductors and submerge them in ocean water, which contains naturally occurring salts like sodium, calcium, and magnesium. These ions allow an electrical current to pass from one conductor to the other, creating a positive anode on one side and a negatively charged cathode on the other. In turn, the positive charge of the ions in the water draws them all to the cathode, where they accumulate into a mineral layer, or what Wolf called biorock. In pictures provided further down, we can see the products of this process, where 2 conductors have become fully encased in mineral deposits. And it was with this accretion technology that Wolf hoped to finally achieve his vision of Cybertecture, which, if we flip all the way to the end of this paper, we can see an updated illustration of what exactly this meant. By this point, he had abandoned his ideas for an underwater city in favor of a much more practical island built from the ocean floor up to the surface, a plan that's admittedly still a bit ambitious, but one that Professor Wolf Hilberts nonetheless believed in. Though, I don't know, I can't say I'm convinced. After all, a material as strong as cement that builds itself kinda sounds too good to be true. And considering the entire premise of this plan hinges on the concept of mineral accretion, I needed some kind of proof that it was, possible. So I reached out to somebody who I think really embodies the mad scientist spirit of Wolf Hilberts, Cody from Cody's lab, in the hope that he might be able to recreate some biorock of his own. Sure enough, after some experimenting, he did manage to produce this, a thin but real layer of minerals. If you want to know how exactly he did this, you'll of course have to check out his video, but long story short, even after a bunch of work, he couldn't get it to accrete much more than this. Though in the end, I think this still serves as a nice little proof of concept that Wolf's mineral accretion technology does actually work. As an added bonus, Wolf found that once even a thin layer of biorock had accreted onto a metal frame, corals were a lot more likely to attach themselves to it, helping to build it up even more. To tell the truth, the prospect of biorock materializing seemingly out of nowhere and creating new habitat was nothing short of miraculous, and so for the next decade, Wolf traveled the world running workshops teaching people how to set up these structures and electrify them to attract corals. And this can really only be seen as a positive development in the world of marine restoration, as for the first time ever, it gave people the power to start growing coral reefs wherever they wanted, allowing damaged reefs to be repaired and new ones to be started, opening up a whole new world of possibilities for ecosystem engineering. Had that been Wolf's ultimate goal, he likely would have died a very satisfied man, but according to him, he still hadn't quite achieved Cybertecture. You see, while this biorock may have used naturally occurring elements, the energy it used to accumulate said elements always had to come from outside of the system, in the form of batteries or generators. If this was to be a truly sustainable solution, a truly cybertectural solution, then the energy had to come from within the system. Looking back to corals for inspiration, they attain all the energy they need from absorbing sunlight, so Wolf needed to find a way to power his machines in the same way. Lucky for him, this was around the same time solar panels were first becoming widely accessible, which is how he came up with the final design for what he called the Coral Ark. From what I can tell, it consists of a triangular metal lattice secured to the sea floor by 3 legs and a central anchor, which together support a mast reaching just high enough above the water to carry a large solar array. In theory, this structure could harvest the power of the sun to provide itself with all the energy needed to build its own limestone body, just like corals do, and thus represents a true integration of evolutionary processes into technology. If Wolf could complete just one of these pylons, not only would it serve as the first real proof of cybertecture as a concept, but then he could also convince people to invest in building more and more of them, until they formed a solid foundation upon which a city could be laid. Knowing this, by the early 1990s, Wolf started scouting out locations to construct a test of this coral arc, and by 1997 he revealed he had finally chosen a target site through an interview in the magazine Popular Mechanics. Here he explained how 300 miles off the coast of North Africa he hoped to construct a home in the middle of the ocean, a place he'd already named Autopia. If you're curious, 300 miles off the coast of North Africa is where you'll find the Ampere Seamount, the perfect place to test out a plan like this, given its proximity to the coast and its strategic position at the mouth of the Mediterranean Sea. He goes on to describe how Autopia Ampere will begin as a series of wire mesh armatures anchored atop a sea mountain. Once in place, they will be connected to a supply of low-voltage direct current produced by solar panels. Over time, electrochemical reactions will draw minerals from the sea to the armatures, creating walls of calcium carbonate. Through this article, Wolf again lays out his entire plan in an attempt at convincing its readers of its feasibility. Though no matter how scientifically sound his idea may have been, Wolf was also aware that he was going to need to do more than just convince people to believe in him. What he really needed was to convince people to invest in him. This is why he went on to explain how one of the cornerstones of the new city's economy would be limestone farming, where Hilberts envisions these products being lifted directly out of the sea into barges and ships which could deliver them to seaports around the world. Though if you ask me, growing limestone, a material readily available on land, probably would not have been able to provide all the funds necessary to support such a city, which is why Hilberts also envisions others of his cities becoming centers for an undersea mining industry, as the sea floor is believed to be littered with metal and mineral-rich nodules from which refiners in a city will produce pure metals. And this, I believe, is the true crux of Wolf's ambitions, to figure out a way to inhabit the deep sea in order to take advantage of its natural resources. Whether he realized it or not, what Wolf was trying to do was pioneer a way to colonize the ocean, claim it for himself, and exploit it. A goal that ironically threatened the very success of his efforts, as not a single country was willing to give up territory off its coast to such an obvious attempt at starting a micronation. Wolf even said as much in this article, as the fact that ocean-grown cities could stand on their own economically and become independent and self-governing entities poses what Hilberts believes to be one of the biggest barriers to their creation. He says there is no legal precedent regarding national ownership of a newly formed island that is beyond a nation's territorial waters. Like this, we can see Wolf knew exactly what kind of mess he was getting himself into, as he plans to face this issue head-on with an experiment on Skerki Bank in the Mediterranean Sea. The bank consists of a few hundred square yards of knee-deep water between Tunisia and Sicily. It's in international waters, but within the area both Italy and Tunisia claim as exclusive economic zones. As you can see, Skerki Bank sits right in the middle of the Mediterranean, protecting it from the storms of the open ocean, making it easier to transport materials to, and gaining access to valuable trade routes, and thus makes perfect sense why Hilberts hopes to start growing an island there before the end of the year. He said, "We'll establish our presence there and stake a claim and see what happens. If anyone challenges us, we have lawyers ready to argue our case." We've had so many legal opinions that we decided just to go ahead and see what happens. Unfortunately, I couldn't find any details on whether or not Wolf actually went through with this attempt to stake a claim on Skirky Bank, or how the Italian and Tunisian governments might have responded. But I assume he did, and I assume he very quickly learned how little the Italian and Tunisian governments cared about what his lawyers had to say. Unsurprisingly, no country was willing to support an attempt at creating land and annexing territory within their territorial waters. And so if Wolf really wanted to test out his coral arc and prove himself once and for all, he'd need to find another shallow expanse of water far from the authority of any government. This is what led Wolf to begin looking into the Saya de Malha bank, as the Seychelles territorial waters only extend this far, and Mauritius can only make claims as far as the Nazareth Bank, leaving the entirety of Saya de Malha in international waters, where no one held the jurisdiction to tell Wolf what he could and could not build. This is why by the end of 1997, Wolf made a preliminary visit to this area to scout out a new site for what he was now calling Autopia Saya. However, there was still one last obstacle standing in Wolf's way: funding. It turns out designing, fabricating, transporting, and constructing an enormous metal contraption entirely underwater hundreds of miles from the nearest land is quite an expensive endeavor, and definitely one that Wolf wasn't wealthy enough to fund on his own. Worse than that, despite the scientific basis upon which he built his plan, from the outside this scheme appeared too bizarre, too out of the box, or too revolutionary to receive proper funding. So what did Wolf do? He pivoted. First, he brought Thomas Garreau, a world-famous coral biologist, onto his team to be the science coordinator of an expedition, who in turn hired Frank Gutzeit to handle logistics, Gabriel Despain as the dive coordinator, Stephen Evans, a cartographer, Peter Garreau, Tom's brother and a geophysicist, Casper Henderson as an author and consultant, Caroline Mecke, the resident marine biologist, Roman Obrist, a merchant marine and engineer, and Hartmut Kubica, captain of his own small fleet of ships. Suddenly, this expedition looked a lot less like one mad scientist's attempt at building a secret lair, and a lot more like a legitimate team of researchers hoping to visit one of the last unexplored corners of the Earth. This made it much easier for research institutions to get behind, which is how Wolf eventually secured funding from the Lighthouse Foundation based in Hamburg, Germany, enabling this whole expedition. Like this, we can see it was Wolf's goal of achieving Cybertecture that was the force that brought this whole expedition together. And by March 6th, 2002, Wolf and this team had assembled in the Seychelles harbor of Victoria, with 3 boats in their command, ready to embark. However, if we continue reading the travel log, we'll find this expedition would be cursed with bad weather from the very beginning, as Tropical Storm Harry rolled through the area the same day they were meant to set out, delaying their departure until March 11th, wasting 5 whole days before the trip had even begun. Once they finally left Victoria Harbor, it took 3 straight days of sailing across the Indian Ocean until on March 14th they arrived at their destination. Naturally, the very first thing Wolf did was jump in the water and check the structure erected by the Saya Expedition 1997 on the sea floor. Now, I'm not quite sure what exactly this was meant to test, but whatever it was, after looking it over, Wolf must have considered it a success, as immediately after, preparations for construction are made and cutting of steel profiles is begun. Unfortunately for him, the weather would continue to be uncooperative, as the next day there were swells and a moderate breeze. This must have made welding and arranging the metal structure difficult, so instead the next 2 days were dedicated to performing surveys of the sea floor, the placing of scientific recording instruments, drilling cores of the upper calcareous seabed, and bathymetrical mapping of a selected portion of the North Bank begins. Or in short, it was only while work on the Ark had stalled that all the other scientific work was carried out. Though by March 18th, the ocean had finally calmed down, making a flat sea with only a moderate breeze. Perfect weather for building something underwater, which is why we can see welding work is started on the coral Ark Saya star. And by March 19th, the Ark is launched and positioned. When I first read this, I was actually really impressed, as it makes it seem as though Wolf completed his original plan in just 2 days. But if we continue flipping through this, we'll find the only picture of the Saya star looks absolutely nothing like the original intended structure. Clearly, a change in plans had occurred, and we can find more evidence for this by March 20th, when slight waves had rolled in, which allowed for work on the photovoltaic raft to begin. If you'll remember, originally the coral Ark was meant to support solar panels atop a solid mast, but the revised Saya star no longer reached out of the water, so instead of a platform, the solar cells had to be launched on a floating raft and moored to the star. Why exactly Wolf changed his plans, we'll learn a little later in this report. But for now, whatever the cause, by March 21st, the expedition again experienced only slight waves, allowing for corals to be placed on the Saya star and for work on the solar raft to continue. Anode cable connections are encased and all cables are prepared. Mooring chains for the solar raft are fashioned to the Saya star and a huge dead coral head. By this point, all seemed to be going well, but then on March 22nd, when the sea was flat and there was hardly a breeze, the Weather Service reports an area of convectivity northeast of Saya de Malha, moving towards us at 10 to 15 knots. We will have to leave as soon as possible. There is time only for the most essential tasks. And I just think that last part is so funny because according to Wolf, those essential tasks include more corals being attached to the Ark, launching and mooring the solar raft, and deploying the anode and connecting it to the cathode cable. Like this, we can see exactly what Wolf considered essential to this expedition, as he very clearly spent its last hours scrambling to get everything set up before Tropical Storm Ikala arrived. An effort that we can actually see paid off, as by late afternoon, hydrogen bubbles are forming on the Saya star. We have an accreting coral Ark. It appears Wolf actually succeeded in setting up his experiment, and it was only after this was completed that they retrieved all the other scientific recording instruments which had been deployed upon arrival, and immediately after left for Victoria, bringing the Saya de Malha 2002 expedition to an end. But I'll be honest, I still have a lot of unanswered questions. Did Wolf really succeed in building his coral Ark? What caused him to change his plans midway through? And again, was this all worth it in the end? To figure all this out, we need to keep flipping through this report until we get to the results. As if it wasn't already clear just how central this experiment was to the overall expedition, it's the very first thing reported on after the log. Here we can read to learn how time, deteriorating power supplies, lack of manpower, and rapid wear of crucial tools combined to prevent the construction of a coral Ark which upper section would have reached out of the sea, designed to carry a powerful array of photovoltaic panels. Or in other words, we can see how the bad weather very much limited the time Wolf had to work, and the remoteness of the area meant they had access to only a limited supply of power, a limited number of people, and had limited tools at their disposal, which altogether limited what Wolf was able to accomplish. This explains why he opted to design and construct a scaled-down version of the Ark, powered by photovoltaic marinized panels carried on a moored raft. In this way, the Saya star can't really be described as an island, but more like an artificial reef, something Wolf had already built countless times before, and the only thing that truly set this experiment apart from the rest was the solar raft. But even still, we'll read how the cathodic cable was connected, and soon afterwards hydrogen bubbles formed on the Saya star, the sign of beginning mineral accretion. What this means is that despite all the difficulties, all the setbacks, all the bad weather, and all the haters, at least on paper, this experiment appeared to be a success, as Wolf Hilbert's technically succeeded in erecting a structure that could build itself over time, powered only by its own source of energy, all the while helping to support local ecology. So in a sense, you could say Cybertecture had been achieved. Which leaves us with one final question to answer. Was this all worth it in the end? While this is of course a subjective question, I believe if you asked Wolf, the answer would have been a resounding no. While he might have technically proved Cybertecture as a viable concept, this was something he was already convinced of, and what he hoped this expedition would really do was convince everybody else of this as well. Unfortunately, but not unsurprisingly, because of the scaled down nature of the final product, this experiment failed to make much of a splash, and if anything, convinced people that building something like this was even harder than one might expect. And because of this, I can't help but feel Wolf would not have been satisfied with these results. And so, despite all that he'd accomplished back in March of 2002, as late as 2004, Hilberts was interviewed saying, "We are busy now organizing a third expedition to get Autopia Saya growing above sea level." Unfortunately, that would never happen, as Wolf Hilberts passed away suddenly in 2007. While his research partner Thomas Garreau has since stated that he'll be continuing their work, it's been over 20 years since this expedition and I haven't found any updates. And so to my knowledge, the dream of Autopia died with Hilberts. Ultimately, this experiment accomplished little in the way of revolutionizing life at sea, and thus through this lens could easily be considered a failure. But that's what I find so amazing about this expedition, because if you ask me, it was a resounding success. Not because of what Hilberts accomplished, but rather because of what the remaining 70 pages of this 100-page report contains. This is where we'll find some of the first maps, images, and 3D scans of this bank ever produced. After that, there's an entire section devoted to its geology, including analysis of the many core samples taken. Then, the report includes a full biodiversity inventory, cataloging each and every living thing witnessed here. So much of our understanding of this remote seamount comes from this one fateful expedition that, by comparison, Wolf's little experiment hardly even mattered in the grand scheme of things. And so, while Wolf might have failed his own mission, the work conducted here by other people like Stephen Evans, Peter Garreau, and Caroline Mecke was of huge scientific value and well worth the effort. And I just love that, how one man's wild dream unwittingly became the impetus for discovery and bona fide scientific research. For these reasons, I really have nothing but admiration for Professor Hilberts, as he was clearly passionate about both science and nature and wanted to build a better world using them together. That being said, I can't help but point out what Wolf was trying to create would have done more harm than good. While I don't doubt he saw this technology revolutionizing how we interacted with the ocean in a positive way, what he was really figuring out was just another method of colonization with the purpose of resource extraction. And while Wolf might not have been aware of this, deep sea mining is incredibly destructive to life on the sea floor. And so if this really was supposed to be the economic driver behind these settlements, then their entire existence would be predicated on the destruction of the environment, the very same environment Wolf hoped to protect. Even more so than that, however, if establishing a presence on a seamount became a legitimate method for gaining sovereignty over territory and resources, how long do you think it would take before governments, or even worse, corporations, started doing the same exact thing? Realistically, had Autopia Saya worked out exactly as Wolf had intended, it would have kicked off a colonization effort of unprecedented scales, the scramble for the oceans it would have been called, followed by a wave of ecological devastation. And if the pursuit of cybertecture ultimately leads to the further exploitation and degradation of this planet, well, then I don't really think it's something worth pursuing. Like most people who embark on plans of this sort, Wolf fell victim to a vision of utopia, a place where man interacted with the ocean in a mutually beneficial way, solving all the economic and ecological problems we were causing on land. While this might have been a pretty picture, it prevented Wolf from seeing the truly hellish industrialization of our oceans that inevitably would have taken place as a result of his efforts. Ironically, it was this very same capacity for economic and political independence that made countries reluctant to work with Wolf in the first place, which in turn is what forced him to seek out such a remote test site. And it was the expenses and difficulties associated with venturing all the way out here that prevented him from erecting his coral ark as planned. And so, in the end, it wasn't the science or the lack of support or even the weather that prevented Wolf's plan to build an island using only electricity from being seen through. But rather, it was what he planned on using the island for that ultimately kept him from achieving his goal.